This is Marco from eeprogrammer.com. Um, I'm going to talk about how to use MATLAB to do some signal processing analysis. Um, and how can we use some specific function of MATLAB? So this time we have a transfer function. Uh, this transfer function is quite simple. So we want to put this transfer function into MATLAB to let MATLAB to recognize we are doing some signal processing stuff. Okay, so how we do it? So first of all, we go to MATLAB. Okay, we need to put in the numerator. So we put in numerator is equal to 0.50. Let's go back to our original function. So here it is. It's 0.5s over s squared plus 30s plus 10 million. Okay, so we need to set the denominator. Let's call it dn 130 10 million. Okay, to let MATLAB know I'm going to, well, I mean right now MATLAB just thought this two is just a numerator 1D array, a denominator 1D array, and the numerator array contain two numbers, 0.5 and 0, denominator array contain 130 and 10 million. So how can I tell MATLAB that is a transfer function? So let's call the transfer function called G. We tell MATLAB G is equal to the numerator and the denominator. And well, you need to recognize the first element is the numerator, the second element is the denominator. So okay, so G right now knows the numerator and the denominator are the array is represent a transfer function. So most of the time, what are we going to do? We need to look at the bode part on the on the um, on the system. So we do a bode. Let's do a bode part. Oh, okay. There we go. So what we can see is, we can see it come up with the emitter port and the phase port. So the command to use it is bode. But how many points are there? How many points are in this port? Most of the time, this is just a limited number of points. Sometimes 50. So how can we check how many numbers on the graph? So we can click on this figure 2, and then we can choose more property. And we can select the marker to be false. So you can see that basically this part doesn't have too many pawns. So how can we do it? How can we do it in a more pawn? If we want more pawns, what should we do? It seems that at this point we don't need more pawns. If we need more pawns, what we can do is we can do a log space. Let's see what is log space. So basically is log space x1 is equal to the initial pawn, x2 is the ending pawn, and is the number of pawns in between this. So we do a big log space. Let's call it we do a large array for the log space. Let's do it called W. W equal to log space. We can define it like -3 to 5, even 7, with how many points is it? 1 million. 1 million pawn. So it creates 1 million 1 million equal space pawn in the log space. So now we do the bode again. Okay. So now we select this. We select the marker. We see it is still like just like a few pawns. This is not like a million pawns. So what do we do wrong? Wait. Basically, we have to input. We have to tell the bode part we are using many pawns. You're using the W array. So we do it. G is the system. W is the log space array. So there we go. When we click on the line and we select the marker, you see it become a fake line. What that means is there are many markers overlap each other. So right now we know the bode part apply the W array.